Yes, we are live now. So I welcome Ameer Jhan for this podcast, for this event on containers for rest of us. Trust me, last week I was in this event and I really thought to myself like I need to build myself like one of the professional like what he is. Like his explanation was on point and I literally loved that session. So what I did was I approached him once again and we are back here doing the same session but like in a different fashion. Trust me, you're all going to enjoy this webinar where we are trying to demystify a lot more beyond what containers to the world. And I welcome Ameer Jhan and thank you for giving this webinar, sir.
Sure, thanks for having me, Vishwas. So it is great, always sharing what you know and also answering questions and getting to learn from the audience.
Yeah.
So without any delay, as Vishwas pointed out, I'm Amir. You can find me as Amir the Hacker and most of the social medias. I used to say that.
Ameer, your voice is like a little
Okay.
low. Your
Okay.
voice is like a little low.
Uh, just a minute. Uh, how about now?
Yeah,
Yes, sir.
it's good.
Good, cool. So you can find me in all social media using this username, and I work as a senior software engineer at HackerRank. So you guys might most of you might know HackerRank, but if you don't know, like we kind of try to match developers to the right organizations, or we are trying to make the world flat. That anyone from any part of the world should be able to land on a dream developer job by having a good skill set. Right? That's what we try to do. And a little about me. So I maintain a React lazy load library called like 4K. So I'm actually a huge open source enthusiast. So I build small tools for myself and others who try to use it. And I write a lot in free code camp. But recently I have not been doing much. But yeah, so I'm a huge Marvel fan, huge Iron Man fan. And the cat person has a cute two cats in my home. Probably next time when we meet in person, I might probably bring them also. And yeah, I love stickers. I have a lot of stickers on my laptop. And today's webinar is around containers for rest of us. So some of you might be actually be confused with what this actual title means, right? Like if you take containers, a lot of us are kind of get scared by hearing the name containers, right? Because they are like we use containers in our daily lives, but we are kind of like we are still not able to build the right mental model, and at the same time we are not able to get the fundamentals right on what container is. So in this webinar, we'll try to build our own container, right, and try to get the fundamental and also the mental model right, so that you wouldn't feel any fear towards containers, and it would like you would feel right home whenever you do some container stuff, right? So if you go to Google and ask Google like what containers is, this is what Google says: containers are isolated from one another and bundle their own software, libraries, and configuration files, right? This is kind of very vague, right? Out of the box, you have no idea what actually means. You can get some idea that they are isolated, they come with their own software and library and configuration files, but actually what does it mean, right? So let me take you to the through the rabbit hole. It's gonna go deeper. So sit tight. So this is gonna be like we will be visualizing actually what this definition means. So just kind of keep it in your mind what this definition means. Right? I will try to make sense of each and every word in this definition. So in this journey, the step one for you guys is to forget containers. Don't think about in terms of containers, right? Like think that we are in a world where there are no containers, right? And in step two, we are gonna try to build the following thing using the following requirements. So someone comes up to you and he says, "I want these 3 points to be implemented." So these are the three requirements that someone is asking you. The first requirement is they want your program, whatever program you're running, to avoid killing other processes, right? If you are running your application, like let's say you're running HTTP server, it shouldn't be able to kill other processes. That's the first point. The second thing they want is that they don't want your application to be updating the host name. Host name is nothing but a unique DNS name assigned to every machine in a network. So if a process is able to update the host name, it's kind of it's a security risk. So they don't want any program or your program to be able to update that, right? And it wants you they want you that any program that you run shouldn't be able to read a secret file, right? You're running HTTP server, there's a secret file in your file system, it shouldn't be able to read that. right? So that's those are the three requirements. So we are going to try to build something which kind of matches these three requirements, right? So that's what we are focused towards today. So before we start to actually build that thing, let's get our fundamentals on operating systems right. Right. So if you take a small C program like this right here, what it's actually trying to do is it's just trying to open a file. It's trying to open a file.txt in read mode. Right. So it's so underneath this is what happens. So for each function call that you make in a C program, let's say fopen, that's what we called here. It actually internally calls a syscall, a system call, which is operating system specific. If you take Linux, in that case, it's nothing called something called
Amir, a
open.
little zoom, a little bit of zoom,
Okay, does this
a little bit
look
more.
fine?
Like it's like, yeah, this is fine.
Okay, cool. So if you take this fopen function, it's calling a system call called open, which is going to try to open a file. And when we are doing it, we go through a process called space switch. Right? Whenever your application is running, by default, it's in something called a user space. So a user space is kind of pretty much limited. You wouldn't be able to do a lot of stuff. But at the moment we are trying to access a hardware, for example, in this we are trying to access the disk by trying to read a file. Or if you are trying to access some other hardware, we switch into something called a kernel space. A kernel space is a more privileged space. That's the handoff happens from your program to the kernel. So kernel is nothing but the heart of the operating system, and the kernel takes care of interacting with the hardware. So here the kernel interacts with the disk and reads the file and gives back to your C program, and you're back at the user space. Right, so this is what happens when you do write a simple file reader in C program. Right. So what is a space? A space is nothing but an abstraction of resource. If you take disk, if you take keyboard, everything is abstracted into a space, and each resource is grouped together into a namespace. Right? If you take a namespace called network, Ethernet, all the HTTP traffic, all those are grouped into the namespace called network namespace. Right? Some of the namespaces that are available in Linux are called process ID namespace. So this namespace actually holds the resources using which you can read the processes, list of processes, their process IDs and stuff like that. There's something called mount namespace. Mount namespace is nothing but the disk resource. So if you want to mount a disk, you want to unmount a disk, or you want to read from a disk and all those stuff. Actually, a file system, I would say, if you take mount namespace. Then there is also called Unix time sharing. It is nothing but if you go to the history, you would find that initially everyone had a huge mainframe, and clients would connect to them. Thin clients would connect to them using something called time sharing mechanism, in which every client is given a fair share of time through round robin. So during that period, they use something called hostname, which still kind of remains in Linux operating system for the legacy reasons. So that comes under the Unix time sharing namespace, and obviously the network namespace, right? So by default, whenever you run a program, it's a program 1 or program 2, they run on a global namespace. In this global namespace, every process shares the same namespace, so everyone is able to access every other namespace. So if you are trying to access process, program would be able to see the program will be seeing the same list of process. Program 2 will be also seeing the same list of process, because it's the same namespace. Everyone is named namespace, right? So if you take program 1, it is kind of creating a child process by using a fork method. And at the same time, it is creating a new namespace. Rather than creating the child process in the global namespace, it is creating a new process under a new namespace called namespace 1. So the advantage of this is the namespace that the child process is in is totally different from what the program 1 and program 2 are in. So the child process wouldn't be able to get resources from the global namespace. Right. So in Linux, everything is grouped into namespace, and whenever you launch a program, it goes into the global namespace. But at the same time, you have a system called unshare, using which you can create a new namespace and put a child process into it so that it doesn't share the namespace your parent processor. Right. So these are the more core concepts of which are very specific to Linux itself. Right. So if you guys have any doubts till now, you can probably shoot it in the chat. Let me know, Vishwas, if anyone has any questions. If you guys are clear on this, we can move on to the next section.
Yeah, they are clear with it. We have another group, so they will be talking with us.
Okay, got it. Cool. So let's move forward. So theory is always good. So let's actually see this through a demo, right? So all the demo that we are going to see is going to work only in a Linux operating system. So probably you can create a virtual machine in Azure or AWS based on your convenience, or maybe have a local VM. Everything works, but have a Linux works. Okay, so I have my terminal, and I'm going to SSH into the the Linux box. So I'm going to increase the font size. Does this look fine? The font?
Yes, a little bigger because
Okay.
yeah, this is better.
This is better, right? Okay, cool. So I'm inside my Linux box right now. Okay, so I have nothing actually right here. Okay, so we were talking about programs, right? Let's say we're gonna start a new program, and the program is nothing but sh. Okay, sh is nothing but another shell. Right now I'm in the bash shell, so I'm gonna create a new process, which is nothing but the sh process, right? So our program is nothing but another shell which we are gonna invoke from the bash shell, right? So from the bash shell, I'm gonna see ps. I can see that my bash shell is running, and the ps was the command I wrote, right? So what I'm gonna do right now is that I'm gonna run the top command. Top command is nothing but gives you all the list of processes that are running in your Linux box, and if you run top with the ampersand at the end, not just top, any command in Linux, it would kind of put it into the background. So it wouldn't show anything no UI would appear, but it's running in the background. I can show you by running ps. If you can see, if I go to ps, I can see bash is running, top is running because I ran it in the background. And this was the process ID that Linux gave me back when I ran it with the ampersand at the end. So the process ID actually matches the what I got from ps. Right, so I'm going to start my program, which is nothing but shell. Now I'm going to again use ps, and you can see now that I can see top. I can kill top by using the process ID. So I'm going to kill the top by copying the process ID. And if I do ps right now, top is gone. If I go exit and do a ps again, you can see that the top is gone. So our first requirement is not yet matched. We started a program, and the program was able to see all the list of processes in our system, and it was able to even kill one of the processes. Right. So how do we kind of ensure that this doesn't happen, right? So as we talked previously, we had something called an unshared system call, right? We had an unshared system call using which you can separate out the namespace. So thankfully, Linux comes with something called unshare utility, which internally uses the unshare system call. So using this unshare command, I can say something like, okay, actually fork a new process called sh, right? I'm going to fork unshare is going to fork a new process called sh shell, and at the same time, while doing it, create a new namespace for the process. So previously we were sharing the same global namespace for process. By using the PID option in the unshare command and the fork option, I'm telling that fork the sh shell, at the same time create a new process namespace. Right. So this is what we're going to do. So before doing that, let me start my top again, and I'm over ps. I can see my top is running, and I'm going to use our process to fork sh shell. But this time I'm going to create a new PID namespace. And obviously you need to be sudo when doing unshare. Right, so I'm in my sh shell. Now if I do ps, you can see the top is gone. All I can see is unshare, sudo, sh, and ps. My top command is not available in the list of PID that I got. But if I exit this and do a ps, you can see my top is still running. But if I go to the same unshare command and do a ps, my top is gone. Right. So using this unshare command, we kind of successfully met our first requirement, in which we don't want our child process, which is nothing but our sh shell, to see the list of process from our parent process, which is nothing but top. Right? That is good. Now let's go into the second requirement, in which we were given the task that the program shouldn't be able to update the hostname. So what is hostname? If you use a command called hostname, you would get the hostname of our VM, right? It's containers -talk-demo, right? In the same command, you can use hostname space a new hostname to update the hostname, right? I can say hostname update as hostname may be edited, right? I'm gonna say hostname. I'm gonna do sudo. So now if I try to do hostname, the hostname got edited. Now let's try to use our same unshare command, right? We did the same unshare command. We are going to create a new sh shell with new process namespace. Now I'm using the hostname command, and it said hostname edited, which is same as we got previously. So I'm going to try to edit the hostname from here. I'm going to say hostname hack from sh. Okay, so I said change the hostname. I said set the hostname here. The hostname got updated. If I exit and I say hostname again, you can see the hostname got updated. So from our child process, which we forked using unshare, was able to update the hostname, which shouldn't be happening based on our second requirement, right? So for that, what we're going to do is that we are going to use the same command unshare. But previously we said just create a new namespace process, right? Now I'm going to say create a new namespace for the UTS, which is nothing but Unix time sharing. As I previously said, all the hostname stuff comes under the Unix time sharing namespace. So if you don't want to update the hostname, then you should be using a new namespace for UTS. Right? If I do this, now if I say hostname, it says hostname hacked from sh, it was previously there, and I'm going to say I'm trying to update it from the sh process. I'm going to say hostname hacked again, right? So if I try the hostname command, it says hostname hacked again in the child process. If I exit and I say hostname, you can see the hostname did not get updated, right? So in this example, we just created a new UTS namespace, which is nothing but the Unix time sharing namespace, and we were successfully able to prevent our child process or any programs that you spawned from unshare to be able to update your hostname. So we have achieved two levels of security. One, we are preventing any program that you fork from killing any other process or getting information on other process. At the same time, you are preventing your child process or whatever process you spawned from actually updating the hostname of your system. Right. So these two are pretty easily be achieved. But let's see how we do this, right? It seems to be pretty not so straightforward, right? Like how do we make sure that a program is not able to read a file in our file system, right? So for that, what I'm going to do is that I'm going to create a secret.txt file, right? I'm going to open the file and I'm going to put all my dark secret in it, okay? So I want any program which runs in our system should not be able to access this file, right? So if I go to sh, maybe use our same unshare command, right? If I do an ls, I can see the secret.txt file. I can even cat it, and I can see the secret file, right? So now how do we do this, right? So the only way to do this is we should actually kind of switch the entire file system for our child process, right? So currently, if you see the child process, whatever is running, it is actually getting mounted on our own Linux box root file system. We don't want that to be happening. That's how we can hide our secret.txt. We don't want to share the current file system, which is nothing but the root file system that we have in our Linux, with the child process. We want a new altogether a different file system or a different Linux root file system for our child process, right? So for that, we have a helpful command in Linux called chroot, which helps you to switch an entire root file system for the sake of creating a dummy file system so that your child process wouldn't be able to see that, right? So for that, what I'm going to do is that we need an entire new Linux file system, right? It shouldn't be reading our root file system. So for that, what you can do is that you can go to Google Alpine or Alpine download. You land into something called Alpine Linux. So Alpine Linux is nothing but a trimmed down version of Linux to be used in embedded hardware. So they have standard version, extended, netboot, everything for specific hardware that you would require. But our specific requirement is matched here for something called a mini root file system. Mini root file system, nothing but the entire Linux but without any boot configuration or stuff like that, because we don't care about boot configurations. We just want a new Linux file system so that we can avoid our child process from reading the our root file system. So if you see, it says that mini root file system, and it is specified it is to be used in containers and minimal CH roots, right? So here I'm going to download our specific architecture. You can download x86 as x86 64, whatever that suits your need, right? So for that, we need to download this in our VM. So I'm going to copy the link rather than downloading it. So I'm going to copy the link address and use wget to download it into our Linux box. So we have the zip right over here, right? And I'm going to create a directory here for us to extract it. So I'm going to say dummy fs, right? I'm going to unzip it. So we're going to extract it. We're going to extract the file. And yeah, so, and we're going to copy it into dummy rootfs, right? So if I do ls into dummy rootfs, you can see in the dummy rootfs, we have an entire Linux root file system, right? So what I'm going to do is that in the dummy rootfs, I'm going to create a small file so that we actually can see we are actually mounting that root file system, right? So I'm going to touch test.txt. If I do dummy rootfs ls, you can see there's something called test.txt. So now what we're going to do is that we're going to switch our entire root file system to the dummy root file system. So for that, you need to use rootfs, obviously with sudo, and we're going to use our dummy rootfs, right? And by default, our Alpine Linux does not have a bash shell. So by default, chroot tries to find a bash shell in our dummy rootfs. So for that, we need to specify what process to start. So I'm going to say, don't look for bash, look for sh. So it has started the sh shell from the dummy rootfs. If I do ls, you can see there is test.txt. So it has actually started a dummy rootfs rather than using our rootfs. So our secret.txt file is not here actually. If you see, there is a home folder. If I go into home folder, you couldn't see anything, right? This is because this is not a real root for fs. This is a dummy rootfs that we use chroot to switch to, right? But at the same time, we are not protected from hostname update. So if I try to update, change the hostname, so use hostname, you can see the hostname says hostname hacked from sh, right? Now I'm going to say hostname, update the hostname to hostname from new root. Right? I'm going to exit it and I'm going to check the hostname. You can see the hostname got updated. So how do we protect it? So we have to use a combination. So we shouldn't just switch the root file system, but at the same time we should create a new namespace for process, Unix times, system and things like that. So for that, what I'm going to do is that I'm going to use the same previous uncheck command, right? If I go, so we are here. So rather than using sh directly, I'm going to say, okay, fork new process. But that process should be forked from this file system. So rather than directly, forking the sh shell from our root file system, fork the sh shell from the new dummy file system that I had, right? bin/sh. Now, if I do that, if I do an ls, you can see still the test.txt exists, but we are in our new file system and we are not able to see our secret.txt file. At the same time, if I try to update my hostname, the hostname here, it got updated, but if I exit and say hostname update, you can see the hostname did not get updated. So in this single command, what we did was, like, we forked a new process from a dummy root file system, which is nothing but alpha in Linux, called sh shell. While forking the process, we told Linux that, create a new namespace for process and the Unix time service, so that it doesn't see the stop process. At the same time, it shouldn't be able to update the hostname, right? So guys, this is the container. Like what we did till now, this single command is nothing but a container. So we literally created a container when we ran this command, right? So this is nothing but a container. So Linux out of the box supports containers. That's why containers run natively in Linux, right? So if you come back to our definition that we had, containers are isolated from one another, right? What does it mean? If you see, our process was isolated from all our parent process. It was not able to see list of process. It was not able to update a host name. It was not able to see our file system, right? So the isolation comes in place by kind of a illusion. So the Linux operating system that says that, okay, you update the host name, yeah, it got successfully updated, but I wouldn't actually update it, right? So we kind of created an isolation by using the unshared system call, right? Unshared system call, and then it bundles their own software. So when we use the new root 5fs, the alpha and root fs, dummy root fs, in that I can install whatever software I want. I can put whatever code I want in that, right? And I can share the same with another person, and he can use the ch root to switch to that and work on that file system while not affecting anything in his root fs, right? So while bundling their own software is nothing but bringing their own root fs and switching to the dummy root fs, right? Libraries and configuration files are nothing but the same, right? When Alpha and Linux gave us the root fs, it had all the configuration, it had all the libraries and things like that. So this is what exactly a container means. A container is nothing but something that you create an isolated process that you create using the unshared system call, in which you can specify that isolate all the namespaces, create a new namespace for the following stuff, so that my process does not update or see those informations, right? Or resources, you can call, right? So now let's build a mental model, right? So unshare is nothing but your container runtime. So unshare is what it was actually creating your process. At the same time, it was who deciding what resources to give to the process and not to give. And if you take Docker, it uses a runtime called container. It handles more edge cases. It handles more namespaces. There are like 12 namespaces, I think 11 or 12 namespaces in Linux. All the namespaces are a new namespace is created for them. We just created new namespace for process and UTS and file system, right? But it creates a new namespace for all the things that are available in Linux, so that the process is very much isolated and sandboxed. And yeah, container is nothing but the Docker's runtime and the rootfs management and other tools, right? So we actually downloaded the alpha and rootfs from a particular website, we unzipped it, and we use chroot. But Docker kind of does it through a nice set of tooling rather than you have to think about what I should download. So all your Docker images or container images are nothing but rootfs. Rootfs zipped into a tar file, and it is actually unzipped by Docker. Whenever you are using Docker pull and an image name, you would see that pulling image, extracting image. It's nothing but it's unzipping the rootfs and mounting it for you in form of a container. Right? That's why we have something called alpha and image in Docker. Right? It is exactly nothing but what we downloaded. It is the same thing that is getting downloaded whenever you use alpha and Linux. Right? So what does all say? What we can infer from this? Right? Containers are faster than VM because they are nothing but another process, right? VMs are kind of a separate thing altogether, where translations happens. An instruction from one operating system is switched to another operating system. Nothing is happening. Nothing so complicated is happening. Container is nothing but another process. It takes the same time as another process kicks in. So in milliseconds, a process kicks in with some level of isolations or namespace isolation that Linux provides, right? So when you download Ubuntu or Alpha image from the Docker Hub, you are not downloading the entire OS. You are not downloading the boot configuration and things like that. You are just downloading the rootfs, and just the rootfs with software. When you are downloading Node.js, not what they are doing is that they are just giving you a rootfs with Node.js already pre-installed, right? So you are not booting an entire operating system at all. It is just a set of files, a rootfs of Ubuntu or Alpine. Right. So the container built for one OS cannot run on other OS. If you take IAS, which is nothing but the Internet Information Service, I think, which runs in Windows, you can find a Docker Hub image. I think if I go for .com, if I search for something like IAS, yeah, Windows IAS. If you try to run this IAS in a Linux system, it wouldn't run. Right? They even specifically specify that it is only supported on Windows, because IAS never runs on Linux. Right? Because the reason behind that is IAS is nothing but is going to be spawned as a process, and that process is going to depend on OS specific steps, OS specific system calls. IIS doesn't work with Linux system calls, so it doesn't run in Linux out of the box. And container image built for one, yeah, that's the same thing that I was trying to say. And you cannot build a container image for a particular OS on a different OS. You cannot build a container for Windows from a Linux operating system. You need to use Windows to build an image for Windows. And only Windows and Linux out of the box support native containers, by which I mean only Windows and Linux have system calls which are very similar to unshare. If you take Mac doesn't have any system call for you to create new namespaces. Right? It doesn't have anything like that. That's why whenever you run Docker in Mac, you would see a new VM altogether, a Linux VM created. Docker doesn't run natively on Mac, but it does run natively on Windows and Linux. Right? So if you go into Windows, you would see an option to switch to Linux containers or Windows containers. Right? So when you switch to Windows containers, it's going to run natively. But when you switch to Linux containers, you would see there should be some kind of a VM, Linux VM created in hyperware, or using the Windows subsystem, Linux subsystem, or it would be using a VirtualBox Linux to build or run your containers. Right. So that's all, folks. That's all actually means what a container means, and that's how you build a mental model around containers. Thank you. Thanks, Vishwas. Hope it was useful.
Of course, it was very useful. Of course, it was very useful. I really enjoyed this. Every time when I hear about containers, nowadays I'm feeling like it's very, very niche topic to me, which I actually had left very earlier. Because I myself wrote 10 articles on 11, 12. I still don't have the count, but like I'm not yet satisfied that there is something more to learn in Docker. I think this was a very, very brief introduction to all the Docker and things like that. I think this South India Summit, the pre-events and everything will be going on for throughout the month. It's happening. Like anybody can give at any given point of time. I think we needed something as in containers because there are other speakers who are talking about serverless, microservices, and things like that. I think this was a very brief introduction to all the containers and orchestration and all the platforms. I think thank you so much, sir. It was an amazing session. I really enjoyed it. I'll just say you people why I'm doing all these sessions. I don't do sessions because you guys will come and I'll start getting some fame. I'm just doing it so that I get a chance to meet great people like Ameer from AWS, from Google, and things like that. So, meanwhile, when we are hosting such events, be a part of it, be the part of the community, be the part of the hustle, learn from us, achieve something more. Thank you so much, sir. Thank you so much.
Thank you, Vishwas, for having. Hopefully, we'll meet again. Bye.
Yep. Bye. Bye, everybody.
Bye.